Okay, this is Anthony Priscilla doing a little algebra, functional analysis with my college algebra class. And today we're discussing functions, and we're going to discuss how to find the domain of functions. Now, we've already said that the domain is the set of x values. Okay, so the domain is the set of x values. That's the domain. And what we're going to want to do is figure out what numbers you can plug in for x. When we look at this first problem here, find the domain of this function. I'll cover up all those multiple choices because you'll get the answer too fast. Find the domain of this function. We sort of looked at this when we were working with solving inequalities already, and we've already discussed something about the denominator of a function. Excuse me, a fraction. If we have a fraction, what's the one number you can never have in the denominator of a function or fraction? 0. A number over 0 is undefined. So on number 10, when it says find the domain of this function, it's asking what numbers can we plug in? Well, to answer that, let's figure out which number we can't plug in. -4. The denominator of this fraction cannot be 0, so x cannot be -4. Well, it can be anything else. It just can't be -4. When we look at the answers, choices that are here, you can sort of figure out, oh, well, which one do y'all think it's going to be? A, B, C, or D? Do y'all want to guess which one? A. Now, does this mean anything except -4? Because that's the answer. What's the domain? The domain would be all real numbers except -4. If we think of a number line, if we wanted to shade every number except -4, that would be all out here and everything over here. Now, we don't want to include -4, so what would we put at -4? An open or a closed circle? What means don't include? Open. Now, do y'all remember how to write the interval notation? At infinity symbols, you put parentheses. So this would be parentheses -4, negative infinity, comma, -4, parentheses or bracket. What goes with the open parentheses? Then you'd say union, parentheses, -4, comma, infinity. So answer A here would be the domain. That's just a fancy way of writing all real numbers except -4. Now, number 11, problem number 11, well, are there any fractions here? Can you just plug any number you want in for x? It might get big, okay? You might want to use a calculator, but in general, if there are no fractions, and so when do we encounter errors on our calculator? If you punch in a number over 0, you get an error, and there's another time. If we take a square root of what? A negative. But if there are no fractions and no square root, the domain is just going to be all real numbers. And the way we write all real numbers is with interval notation, negative infinity to infinity. That would be A. So finding the domain of a polynomial function, or in this case, you could even call it a quadratic function, that's pretty easy. Just, see that? So we don't want denominators of 0. We haven't seen one yet with a square root, but we wouldn't want a negative under a square root. But number 11, if there's no fractions, no square root, the domain's all real numbers. 12, ooh, this one's getting sort of involved. Here we have a function that has two fractions in it. We do not want denominators of 0. So the question is, well, here's what we need to do. We need to exclude all numbers that make the denominators equal 0. Okay, like the first fraction. What would make that first denominator 0? When would we have 1 over 0? Negative 10. What about the second fraction? What would make that second fraction 0? 7. So here's just my thoughts. I'm thinking, okay, x plus 10 can't be 0. So x can't be negative 10. And sometimes you just say, I can do this without writing all of that. Well, yeah, these are just my thought process here, okay? X plus 10 can't be 0, so x can't be negative 10. X minus 7 can't be 0, so x can't be 7. Well, when it's written as a multiple choice, it's pretty easy to figure out which one it is. What's the only multiple choice there that has a negative 10 and a 7 in it? D. So I'm going to go ahead and draw the number line just to show that this is actually saying, it's just a fancy way of saying all real numbers except negative 10 and positive 7. If you imagine a number line, and if you wanted to exclude negative 10 and positive 7, remember when we were doing cut points? For the denominator cut points, every now and then I would say domain cut point, and then I'd realize I only hadn't formally defined domain yet, but I would sometimes call the denominator cut points domain cut points, because that's what they are. We're finding the domain when we're saying the denominator can't be 0. If we were talking about everything else, would you all agree that this is the way it would look in interval notation? From negative infinity to negative 10, not including negative 10, then negative 10 to 7, not including the negative 10 and not including the 7, and then 7 to infinity, not including 7. Very typical test question right there. This is one of those times when your homework isn't going to have any review problems. All 15 problems are new stuff. Okay? By new, I mean new to you, not new to the world of math. So now on number 13, we need to discuss how to find the domain of a square root function. Well, with a square root function, we do not want the square root of a negative. We don't want negative numbers under that square root. Because if you put in square root of a negative, your calculator is probably going to give you an error because you're getting an imaginary number. So the way we're going to do this is just sort of a cut point method, okay, approach to this. We're going to start off, take what's under the square root symbol and set it equal to 0 and solve that for x. What x value would give me a 0 under that square root? Okay, I would move the... So we have negative 5x equals negative 40. Divide by negative 5, and what are we going to get? Yeah, okay, 8. If we plug an 8 in for x, we would have square root of square root of 40 minus 40. Maybe I should get my calculator out. Let's see, if I put my calculator here, I know it looks hard to see it on the projection, but the videos, it looks great. If I plug a 0 in for x, excuse me, an 8 in for x, I'd have square root 40 minus 5 times 8. What's that going to give me when I hit equals? 0. The square root of 0 is 0. Now, let's draw a number line. Locate 8. And let's just test on either side. On one side of 8, we're going to be getting positive numbers under the square root. On the other side of 8, we're going to be getting negative numbers under the square root. Give me a number to the left of 8.
1.
A 1? Okay. Let's plug a 1 in for x. If I plug a 1 in, using my little calculator, I'll move it down like that. If I plug a 1 in, the square root of 40 minus 5 times 1. Is this going to give me an error, or is it going to give me a number? It's going to give you a number. It's a decimal number. Okay, 5.91 and stuff. But over here, if you plug a number smaller than 8 in, you're getting a real number back. You're basically, for square root functions, doing a cut point. Take what's inside there, set it equal to 0. There's your cut point. And then look on either side. Generally, you just need to test one of them, one side. If this one was positive here, what do y'all think is going to happen over here? Negative. Let's go ahead and take a number bigger than 8, like 9. And I'm going to plug that into my calculator just to show you. If you plug a 9 in for x, square root 40 minus 5 times 9. Y'all see what that says? It's that error, non-real answer. Because what's it saying? You're getting an imaginary number. You have the square root of a negative. So if you go to it, it wants you to try to correct it. Maybe change that 9 or something. There's nothing I can do there. I'll just clear it out. So the domain is going to be any number to the left of 8. How do we write that in interval notation? Well, parentheses, negative infinity to 8. Now, was it okay to plug an 8 in? When I plugged 8 in, did I get a number or did I get an error? I got a number, so what does that mean? Bracket or parentheses? Bracket. So if I were actually on my math lab, I'd have to type in parentheses, negative infinity, comma, 8. I was thinking, I hope y'all can tell my 8s from my infinities. So there's sort of a pattern on how to find the domain of a square root function. You've got to take what's under the square root, set it to 0, and then once you set it to 0, look and say, okay, on either side of that number. On one side, you'll be getting positive numbers when you plug into the square root. On the other side, you'll wind up with imaginary numbers, negative numbers under the square root. To make sure you have the hang of it, there's another one, problem number 14. And number 14 is multiple choice. Sometimes students say, well, how does that differ from the one you just did? Well, 14 is really involved. Number 14. There's two things going on here. We have a fraction and we have a square root. So there are two things we want to avoid. We want to avoid getting a number divided by 0 because that would give us a undefined in our calculator. We also want to avoid negatives under the square root. I'm still going to start it off the same way I did on number 13. Take what's under the square root and just solve it for 0. X minus 10 equals 0 means x equals Now, here's the big difference between 13 and 14. On problem 13, we included the number 8. Because when you plug 8 in, you get a real number 5. What about here? If I plug a 10 in, am I going to get a real number on my calculator or an error? I'm going to plug a 10 in for x right now. Plugging in a 10 to see what does that tell me. If it gets me a real number, I'm going to put a closed circle there and include 10 in my answer. If we don't, if we get some sort of error, I'll put an open circle, meaning don't include it. What do y'all think is going to happen? Okay, I'm putting a 10 in. Now, if it's going to give me an error, do y'all think it's going to say error divide by 0? Or is it going to say error non-real answer, which means imaginary number? What's it going to say? Divide by 0? Let's look. Error divide by 0. You cannot plug 10 in here. If you do, you would get a 0 under that square, in the bottom of the fraction. So this is an open circle. So instead of a square bracket like on number 13, what are we going to have? You're going to have a parentheses. Now, which side will we be going to, negative infinity or positive infinity? Could y'all, this is some nice functional analysis. Could y'all just look and decide which side would give me positive numbers under here? Numbers like 11, 12, 13, 14? Or numbers like 9, 8, 7, or negative? Yeah, over here it's where we're getting positive under the square root. So how would that answer look? Well, 10 to infinity. Always put parentheses on infinity symbols, but what about the 10? Parentheses. So I guess just looking at these two together, well, what's the difference? The one that has, oops, there. The one that has the fraction in it doesn't have the bracket. The one that doesn't have a fraction has that little square bracket in it. Now, last one, there's no square root in it, it's just a fraction. So do y'all remember how we were doing the fractions? What's the one thing you can't have in the denominator of a fraction? 0. So we're going to say denominator can't be 0, unlike those that we did over here. Oh, where was? Oh, like problem 10. It was pretty easy to figure out the number that gave you a 0 in the bottom. Same thing on number 12. Here it's going to take a little bit of work. What are we going to have to do to figure out this? Starts with F. Yeah, let's factor it. But I think it factors pretty easily, doesn't it? 1 times 8 or 2 times 4? What would y'all?
1 and 8.
1 and 8. And now what about the signs? To get a negative 7.
Plus negative.
Plus negative. Plus and a negative. Then when we set each one of these to 0, we get x can't be negative 1. X can't be 8. Now it could be anything else. So in words, what numbers can you plug in for x? All real numbers except negative 1 and 8. But of course my math lab doesn't want you to write it out in words. They want you to write it in interval notation. So I'm going to draw the number line. Since we're not including the negative 1 and 8, what am I going to put there? Open or closed circles? Open. And we're talking about everything else. Ugh, that's going to take a lot of typing when you type it in, isn't it? It would look like this. Parentheses, negative infinity to negative 1. Parentheses or bracket. Then union. parentheses, -1 to 8, parentheses, union parentheses, 8 to infinity. It's just a fancy way of writing all real numbers except -1 and +8. So these are the last few problems here, finding domains. Some nice functional analysis, if I may say so, here in this assignment. Okay? Any questions there? Well, I'm signing off.